Hi everybody. So now let's continue the work. All right, we have number 8. Two different numbers are divided by 7. Remainder is 2 and 3 are left. What is the greatest possible 3-digit product of these two numbers? Okay. Now first set up the equation. Okay. Two numbers is A and B. Okay. So these two numbers, when divided by 7, same modular system. Okay. When divided by 7 in modular 7 systems, the remainder is 2 and the other one is 3. So the question is asking you product of these two numbers. What is the product? A times B, but this should be what? Greatest possible 3-digit. Okay, very close to 1000, right? So largest 3-digit number is 999, okay? Okay, up to here. We're gonna check it. So product. In the same modular system, product multiplication, right? Product is a multiplication, is working, okay? So we can see A times B, okay? A times B is what? 6 but 7, okay? This is working. So what that means? How can you find the number of 7? Or you can, or you can use this one too. -1 mod 7, right? You can take up same modulus, okay, any times, okay? So actually now from here you can add 1, okay? You can add 1 over here, add 1 over here, okay? So A times B plus 1 equals 0 mod 7, isn't it? 0 mod 7. What it means? That means what? A plus B, A times B is 1 is what? Multiple of 7, right? Because when divided by 7, remainder is 0, okay? So this number should be multiple of 7. But now let's find close multiples, okay? 999, you can divide it by 7 again, okay? Try this one. 10, 29, 28, 19, 14, 5, okay? So when you take up 5 over here, 994 is a multiple of A, B plus 1, okay? So AB plus 1 equals 994, right? Okay? All right, that is a multiple. So actually how much? When you take up -1, AB equals what? 997, right? Okay, the largest number of 3 digits is what? 993 is the answer. Is it okay? All right. If you choose what is that? 994. Another 7 is how much? 1001, right? The next multiple is 1001. So A times B plus 1 equals 1001. AB equals how much? 1000, right? So product is what? 4 digit. Okay? So you can check this one too. Alright? Okay, now let's go to number 9. An integer has a remainder is 2 when divided by 6 and remainder is 3 when divided by 7. We have different modulus. We have an integer, right? A same number, integer. I'm going to use the n. And this number, when divided by modulo 6, remainder is 2. Modulo 7, the remainder is 3. That's the meaning. Okay, I'm going to use the same number. Okay, so when you have a different modulus number, different modulus. Okay, so the idea always try to make the same remainder number. Okay, how can you make a remainder equal? So take a look. When you add 4, can you see that 2 and 6 difference is 4, right? 3 and 7 difference is 4, isn't it? So you can add 4 same number, okay? This 4 is not 6 and 7, so you can add both sides, okay? Both. M plus 4, M plus 4, isn't it? Alright, so from here we can say n plus 4 equals 6 mod 6, 7 mod 7. You can say it this way. Is it okay? So what is 6 mod 6? 6 mod 6 is how much? 6 mod 6, I'm going to write down over here, okay? 6 mod 6 is the n plus 4 actually. 6 mod 6 is about 0 mod 6, isn't it? You can take up 6, right? So you can take up 7. Also, you can say 0 mod 7, okay? So what that means, this one, what that means. n plus 4 actually multiple over 6 and multiple over 7. That's right. So, or you can use what the LCM property, okay? n plus 4 is what? 0 mod LCM over 6 and 7 is what? 42, right? That's the meaning, okay? So, first we're going to find, okay, n plus 4, right? Okay. So, maybe you can say n plus 4 here. This is the value of n, okay? n plus 4, first number is 42, isn't it? 42. Second number is times 2 is 84. Third number 126, keep going, right? What is the last multiple 42? So maybe you can use it by the 1000, okay? The 1000 divided by 42. So this is 284, okay? So 160 and times 3, 126. It'll be 34, isn't it? So 23 numbers, right? 23 multiple 42. The last number, when you take up this remainder, the last number is what? 966. Okay, this is 966. Also, we can have over here 23 terms. Okay. Okay, now let's find the value by n. Minus 4, isn't it? Minus 4 here. So what is it? The first number 38, second number minus 4 is what? 80. Now keep going. Last number will be minus 80 is what? 962. Alright, so you can add this one. Use what the formula, okay? The sum of arithmetic formula. You know what is the sum of partial sum is what is that? A1 first term plus last term n times n divided by 2. Okay, so first term is 38, last term is 962, and divided by 2 times 23, right? Okay, so 38 divided by 960, well, you can divide by first, okay? What is it? 19 plus 4, 81, okay? That is 500, okay? This is 500 n times 23, okay? So 500 times 23 equals how much? Okay, 11 or 5, okay? That's the answer. That's the sum of all this value of n, okay? Alright, number 10, a and b are positive integers. When a is divided by 7, the remainder is 2. When b is divided by 7, the remainder is 1. What is the remainder of these two numbers? Okay, a squared plus b. Now let's define the a. A is what? Remainder is 2 when divided by 7. So you can say it this way. B is what? Remainder is 1 mod 7. Okay, same modular system, okay? So you can make a squared, okay? Squared is exponent, isn't it? A squared is how much? A squared is what? 2 squared is 4 mod 7. B is still 1 mod 7, okay? Now you can use addition, right? So a squared plus b exactly equals what? 5 mod 7. That's right. So when divided by 7, okay, the remainder is 5 because this number is less than 7, okay? That is the remainder. So 5 is the answer. Now number 11. When 3 digits 618, 343, 277 are divided by positive integer d. Okay, positive integer d. But d cannot be 1, right? Okay, we know that. The remainder are the same. What is the smallest possible value of d? Okay, we're gonna find this modular number, okay? Divisor. So maybe you can set up the equation again. 618, 343, 277. When you divide by d means what? When this is mod d, the remainder same. Okay, remainder is same. That's the equation. All right. So what is smallest positive value of d? This should be less than this number, right? Okay, that's the divisor. Okay, now we know that. Now let's find, okay, what is this? We need some little information, okay? To make a zero modular, same modular system, we're gonna try to, first we can try to write the remainder is zero, okay? So 618 minus 618 minus 343 is how much? This is 5, this is 7, this is 275, okay? 275. R minus R is what? 0, okay? 0 mod d, isn't it? What that means? When you divide 275 by d, the remainder is 0, okay? Actually, maybe you can say d just should be what? Factor of 275, okay? Maybe largest number, maybe 275, okay? Smallest number, maybe the smallest way a positive divided except one is what? Maybe 5. Is it okay? Let me see. 5 times 55. 5 times 5 times 11. That is the prime factor. Yeah, smallest factor. Okay, greater than 1 is a 5. Okay, maybe d is smallest is a 5. Okay, now try the next one. From here, 343 and 277, isn't it? Okay, now let's find out. Okay, 3.277. But you satisfy these two, okay? That's why. So minus, I'm going to use this one. 3 minus 13 minus 6 is what? 6. This is 3, another 6, 66, 0, mod 6. Mod d, okay? That's it. So this should be what? Factor of 66. What is 66? 2 times, 3 times 11. Is it okay? So we got two information. 275 and 66 mod d. Is it okay? So what is the value of d? It should be common, isn't it? It should be the same number, okay? So when you have this one, 5, 5, 11. The other one is what? 2 times, 3 times 11, right? This should be same number, isn't it? So you can choose what 11 over here. It's okay? Alright. So the answer is, the smallest d is 11 is the answer, okay? Alright, or maybe you can multiply this one by 4 again, okay? Times 4 is how much? You can use, okay? Times 4. 66 times 4 is what? 264. Then 0 times 4 is 0 mod 6. The other one is 275, 0 mod d, okay? No, this is mod d, right? Not 6. So when you take over here, smallest number, 11, 0 mod d, isn't it? Yeah, that is the best small number, okay? From here. So this number should be what? 11, right? Okay? Because 11 is a prime number, isn't it? Alright. Smallest number is 11. Okay? Alright, number 12. For a certain natural number and n cubed remainder is 4 when divided by 5. Okay, so we can set up the equation, okay? N squared is 4 mod 5. And another one, cube number, n cube is 2 mod 5, same modular system. Okay, so the arithmetic operation, we can use, okay, exponent, okay, but we cannot go, okay, square root, okay. Okay, can you figure out if you have this one? 10 equals 2, okay, 10 equals what? 2 mod 8. This is true, right? Okay, when divided by 8, remainder is 2. You can make it squared. Okay, sorry then. 100 equals 4 mod 8. That is true too. Okay, when you divide by 8, the remainder is 4, true. But when you go over here, not always true. Okay, when you over here, not always true. Okay, so you cannot make a square root. All right. Okay, this is always true. Reverse way, not always true. Okay, it is okay. All right. So we multiply, okay, times n over here. Okay, so these two goes this way. N cubed equals 4n mod 5. Okay, the other same number, n cubed, is what? 2 mod 5, isn't it? This is remainder 2. This is remainder because less than 5, isn't it? Now you have to find, when you plug in some number over here, you have to find what? Same as remainder 2, okay? So when n is 1, 4 mod 5, not remainder 2, okay? So this is not working. N is 2, what happened? 8. 8 is not 2 mod 5, okay? No. The next one, 12. Yes. When n is 3, okay? When n is 3, 12 mod 5 equals what? 2 mod 5, okay? That's true. Okay, so the number n is 3, okay? N is 3, that's it. We just found this one, okay? So what is the remainder when divided by 5, okay? So 3 divided by 5, you know that, okay? That's the remainder by itself, okay? This is the remainder. So n is 3 mod 5, okay? So remainder is 3 is the answer, okay? All right, number 14. Okay, when Rachel divide her favorite number by 7, his favorite number is n, and by 7 remainder is 5, okay? 5 mod 7, okay? So what will be the remainder if she multiples her favorite number by 5? Or you can multiply by 5, okay? That's fine. So it worked. 5 times n, 25 mod 7. Okay? So we are going to find what? The remainder. We know the remainder should be less than this modular number, okay? It should be less than 7. So when you take over here, minus 7, minus 7, minus 7, okay? Maybe 3 times 7 is 21, okay? You can take up 21, okay? Without changing this number, okay? This modular number. So 3 times 7 is 21. Take up how much? 4 mod 7. Is it okay? So the remainder is 4. Okay, now let's go to the next one. All right, number 14. What is greatest 3-digit number? We need greatest 3-digit number. It's 1 more than multiple of 7. Okay, so that means what? When you divide by 7, remainder is 1. Okay, and 3 more than multiple of 5. Okay, when you divide by 5, 3 is remainder. So the number can be expressed in 2 different ways, okay? So 1 mod 7, but this number should be greatest 3-digit number, okay? So also this number when divided by 5, remainder is 3. We have 2 different moduluses, okay? 2 different modulus. So what's gonna do? Same number over here, okay? Or we try to make same number. How can you make a same number? How? The difference is how much? 6, difference is 2, right? You cannot use this method. When you use 6, the other one is 7. Okay, so when you have a 6, that is 9, isn't it? Okay, that's not working. What about this way? This modular system, you can add a 7 or subtract any times. This is a 5, you can add 5 or subtract negative 5 any times. Okay, so use addition, right? So it doesn't change. Okay, there's nothing in change the value of n. Okay, so what is that? N equals plus 7 is, it should be what? 8 mod 7. Okay, the next number is plus 5 is what? 8 mod 5, isn't it? We need some skill over here, right? So you need some skills. Now we got the same number over here. Now the next number, what is that? You can take up same number, that is better. Okay, n minus 8, actually this number is what? 0 mod 7, also 0 mod 5. Okay, so what can you say? N minus 8 is multiple of 7 and 5. So this is what is it? 0 mod 35. You know, it should be multiple of 35. Now let's find greatest 3-digit multiple of 35. Okay, so 1000, that is, you can use this one too, or 999 is okay too. So 95, take a look. 270, 300, when you have here 8, 280, right? So 20 is left. So actually, when you take off 20, 980 is what? Multiple of 35, right? Okay, so this number, n minus 8 equals 980, right? So what is the value of n? The largest 3-digit number will be 988 is the answer. Okay, so we need some skills over here, okay, to make right same number 8. Okay, so I'll see you next video. Okay, today's video is over 20 minutes. Okay, it's too long. I'm gonna put another video for the next. Okay, all right, thank you so much. You have a good work. Okay, I'll see you again. Okay, bye.